It's time, we'll get started. Please settle down. Welcome to the TEAS working group session at IETF 124. My name is Pawan Biram. I'm one of the two TEAS working group co-chairs. Oscar is the other co-chair. Unfortunately, he couldn't be here this time around. He has an unavoidable work-related conflict, so he sends in his apologies for his absence. We have our secretary, Italo, here. He would be helping me with the session logistics. This is the IETF Note 12. There's a good reason why this is displayed at the beginning of each session. It's a reminder of the processes and policies that you agree to follow when you participate in the IETF. These are processes and policies that cover what is expected of you in terms of conduct, in terms of privacy and intellectual property rights. So please do give it a read, give it a thorough read if you can. You're also encouraged to look at the references that are listed on the slide. If you have any questions, please do reach out to the chairs or your AD. For those of you in the room, please do sign into the session. For those who are participating remotely, make sure your audio and video is off when you are not presenting. If you do want to speak, please join the Meet queue and please do state your name each time you speak. We would be using the Hedgedoc collaborative markdown editor for our collaborative note-taking. A pointer to this has been shared on the list, so please do participate in the note-taking activity and help us capture some quality notes. Also, please do verify whatever you say at the mic is captured correctly in the notes. This is the agenda for today. We have three working group documents on the agenda. We have the TE topology model profiles, which Italo would be presenting. We have a couple of newly adopted RSVP authentication enhancement drafts that Tony would be presenting. We have a bunch of individual draft presentations as well. Louis will talk about DC-aware TE topology model. Zafar would cover in-place bandwidth update for auto bandwidth enabled RSVPT LSP deployments. Kiriti has a 20-minute slot to go over the various MPTE drafts. And towards the end, Louis will give us a quick update on a PCE targeted draft that talks about precision availability metrics. We have had no new RFCs since the last time we met. There are three documents that are in the RFC editors queue. There's one for which we put in a publication request just yesterday. That's the Yang TE document. Much thanks to Adrian for shepherding this work. We have a couple of documents in the post-working group last call bucket that should have been published, for which we should have published a sub-publication request by now, but we ran into a few last-minute nits, and we would like to get those addressed before we pass it on to the AD. We will get those addressed this week. The goal is to have those submitted before the end of the week. The L3T topology document is still it still has a few issues. I mean, there are changes that need to be made in a couple of places in the introduction and somewhere in later sections as well. So we'll work with the editor to get that addressed. We have one document that's currently in the working group last call. That's the ACT and POI applicability document, and we have two new adoptions which are both on the agenda today. We sent one liaison to 3GBP groups. This is for getting feedback on the document that talks about the applicability of IETF network slices for in 3GPP 5G end-to-end network slicing. We got a response from one of them. We got a response from RAN3. They sent a bunch of useful comments. The authors will discuss those on the list and determine how we can address those. We'll talk about that a little bit more in detail in the next deck. We have one more incoming liaison from ITUT Study Group 15. Uh, as always, we would look to CCAM to collaborate with all the relevant parties and put together a response for this. Quick reminder on the IPR process that we follow in TEAS. The authors and the contributors associated with each draft are mandated to respond to the IPR poll a couple of times in the working group process, once just before we adopt a document, and the other is just before we take the document through the working group last call. If an author or contributor is added midway through the working group process, we do expect to see an IPR statement being sent by the respective individual to the list as soon as he or she is added to the document. We do have a working group GitHub. Please do make use of it. If you want to use it for your working group document, reach out to our working group secretary and he will help you with the process. A quick reminder that all the consensus decisions will happen on the list. So even if you have reached some consensus on some, if there is some detailed discussion on a GitHub issue tracker, the onus is on the authors to bring that discussion to the list and get consensus there. Lastly, we do expect the authors of each working group document to send out a working group document status prior to each meeting. Some of you have been fairly diligent in doing that, so thanks for that. If you want to check out interim status, you can always go check out the data tracker or take a look at the snapshot that's available on the working group wiki that we maintain. We try to keep it as current as we can. That brings us to the end of this deck. Let me shift to the next deck. Next on the agenda is the working group document status. Thanks to Italo for helping us compile this deck. As noted earlier, we do have 3 documents that are in the RFC ATS queue. There's one document for which we just put in a publication request. There are 3 on the agenda today, so that leaves us with 24 documents. The status for each of these 24 documents is captured in this slide deck. We do have a bunch of documents that are in the expired state. They are in the bottom left of your screen. A majority of those are also nearing last call, so we would like to urge the authors to revive those and help us take them through the finish line, especially the young ones. There are also a couple of, at least 3 documents that are deemed to be working group last call ready. The chairs will discuss these documents after this meeting and determine when we can take them through last call. As always, I would double click on a select few. For the rest, you can go through the slides and go through the status reports that were sent to the list and ask questions if any. That said, let me jump to slide 3. This is the document for which we sent a liaison request. As I said, we did receive a response from RAN3 as well. Louis, would you like to quickly add your initial thoughts on how you'd want to respond to this?
Yes. So as you said, basically we have received feedback from one of the working groups, so we could expect feedback from others. They mostly, this is the working group on RAN, so they mostly identify the point that all the front haul stuff from ORAN is not part of 3EPP, which is properly fine. So, and for the rest, we will basically fix the comments there. Apart from this public feedback, I have received feedback from another, for the chair of another group. So it seems that other working groups in 3EPP are analyzing the document, so we can expect more feedback. With all of them, we will aggregate and we will produce a new version and basically consolidate all the comments in the new version.
Okay. Thanks, Luis. Yeah, please do propose edits for on the list and have the discussion going while you're waiting for the other comments to correct.
Okay, thank you.
We jump to slide 5. This is the document that is currently under working group last call. Last call ends the end of this week. We haven't seen any discussion on this yet, so please do review it. If you don't have any comments and you've read the document, and if you feel that the document is ready to proceed, please do state that on the list. It's useful for us when determining consensus to move forward. Go to slide 9. This is the NRP scalability document. There was one revision published for this late last month. Mostly editorial changes. The authors believe that they don't have anything else to add to this document. So please do review it. If you have any questions or concerns, please do take it to the list. We will look to progress this along with the other NRP document that we have, which is the status of which is captured on slide 12, I believe. So there was a revision published for this as well. It addresses some comments that Adrian had as part of the NRP selector discussion in MPLS. Those comments have been those proposed edits have been incorporated into the document. We do have a few items in the open issues section. We would look to address those before the Shenzhen meeting. The goal is to progress this and the NRP scalability document together, as noted earlier, and hopefully we can get there before the next meeting. In the meantime, if you can review the document and reach out to the authors in terms of what else can be added, that would be very useful. If needed to expedite the process, we may consider having an interim on this topic as well. We have a couple of young documents for which we haven't initiated young doctor review. Those are the NRP young document, and the other one is the young topology filter document. The young topology filter document, which I believe is on slide 25, yeah. So this is deemed to be ready for last call. So while we wait for the young doctor review to be complete, please do review the document and reach out to the authors if you have any questions. So those were the documents that we had that we wanted to cover as part of this deck. Are there any questions with respect to any of the other working group documents that we have? Okay, thanks. We seem to be breezing through. Let's go to our first presentation. That would be Italo.
Okay, hi everybody. I'm presenting on behalf of co-authors and contributors an update to the T-topology profile data model. And what is the motivation? No. Okay, right. Good. The motivation is that there are multiple discussions in IETF working groups or also outside of IETF about the applicability of the IETF topology RFC 8795 to particular scenarios where you need a TEA-aware information, but the network is not what is sometimes called non-T, or we are now using the term non-T-centric. So this information is not used to drive the path computation or the steering of the traffic toward a specific path, but is used for other purposes, like, for example, somebody is using this for what-if analysis and so on. And you need the same information, but it's just for a different purpose than just computing a T path. And sometimes we have a scenario where you need just a subset of information which is provided by the RFC 8795 and not the whole set of information over there. Some of the reaction is, okay, if you look at the model, it looks very complex because there are a lot of features, a lot of data nodes, and this is because we are supporting many features. Some are applicable to T-centric scenarios, some are applicable to more generic scenarios, including T-centric and non-T-centric networks. And most of these features, almost everything in this topology model is optional, so people can really implement the subset of these attributes that are needed for the specific use case. So the objective of this draft is to clarify that you can implement a subset or a profile of this network or this topology model to target to some specific scenario, which may include T-centric as well as non-T-centric scenarios. Example of profile can be if I need to discover a unit topology, so what are the links at the edge of my network is something which is provided, is information that is provided by this model. Or you can discover the administrative operational state of the different topological elements is there. The navigation between underlay and overlay topology is also in this model. There are nodes which are not able to support full mesh connectivity, so not every TP on the node can talk to each other, so there can be some switching limitation of the node. You can express just connectivity's limitation using this topology model, and you can also support multi-point links, and this is a new scenario example that has been added in this update. So what we adapted, after the last working group adoption, we received there was a long discussion on the list about the term non-TE, because it's very controversial what is TE and non-TE. So what we did in this draft, we defined the concept of TE-aware. So TE-aware means you need to have information, you need to be aware of the information that is defined in 8795. And TE-centric is where you use this information to set up to compute and set up traffic engineering path, and not is something where they use the information for other purposes. It doesn't need, the path is still used, is still decided by the IGP based on its own policy, but you can still use this information for monitoring where the traffic is, or to navigate from overlay and underlay, for example. And we noticed that, and now to avoid the problem of focusing too much on TP, we are saying, okay, we are discussing, this is the YAN topology model defined in 8795. Don't emphasize too much, maybe the fact that it's a T term. We removed the reference to RSC 9408, which was a comment we received during working group adoption. And we added clarification about the different semantic of the supporting relationship between node and TPs, which is defined in 8345, from the underlay and overlay relationship, which are defined in 8795. And we added some description, new profile, where we can show how we can model, using this topology model, multi-point and point-to-multipoint links. So basically, as suggested, defined in 8345, the multi-point link is modeled as a pseudonode, but if it is point-to-multipoint, there are some connectivity constraints, and the connectivity constraints of the multi-point link can be expressed using the connectivity matrix defined in 8795, and plus few minor editorial updates. Okay, this I summarize a bit how we can use 8345 and 8795 to model multi-point links. Is basically the concept suggested there is to have a pseudonode, and the pseudonode is defined in 8345, and the TP that are connected to the pseudonode may have different directions. So it can be bidirectional. It's a bidirectional TP is basically having two links in the two directions, entering and leaving from the same TP. It can be just ingress, so you can the multi-point link can only receive traffic. In this case, you have an ingress, you have a link entering into the ingress TP, and there is no link outside from the ingress TP. And you have an egress link where the traffic can go out but cannot come into the link. And if it is point-to-multipoint, you can use the connectivity constraint to say the traffic can only go from the root TP to the leaf TPs. Then you can also support the pseudonode, which is represented in multi-point link, may have an underlay topology, and you can use the 8795 underlay topology relationship to say, for example, the pseudonode in the IP layer is actually supported by this topology, which bridge network, which represents the layer 2 topology, which is supporting this pseudonode. Or we can also have, and this is something we need to discuss in Ivy, is how to associate the pseudonode with some physical infrastructure, which can be, for example, a physical bus. So this will be the association between a pseudonode and a physical resource. What are the open issues? The only open issue that we have today is how we want to report to the client what are the profiles implemented at the server, and this somebody suggested using the deviation, but deviation is too coarse because deviation is on the server basis. The type of profile may be different for different instances or even different network types. For example, we discussed that in the macro topology, the connectivity constraint is not needed because there is no connectivity, but in OTN you may need it. So you cannot say it's not implemented. It's not implemented on this network type, or maybe if you report some instance, on that instance you implement a profile A, on another instance you implement a profile B because it's implemented for a different purpose. So it's more granular, fine-grained than just the whole server like the deviation. So the proposal we have is that addressing this issue it should be outside of the scope. The scope of this draft is just inform people that a profile can be and have been implemented of this model, and we can trigger discussion and further work either in network working group if you want a solution which is generically applicable to any young data model, because I think the need for profiling young data model is more than just the topology. It's more than that. There are many models where you may not implement everything based on the specific use case, or we may need a BIS or a new augmentation within TEAS to just address the profiling of the 8795 topology, if we think that is only applicable to this use case. But anyhow, we think this is outside the scope of this document, which the purpose of this document is to give informational, it should be an informational RFC that describes the possibility to do the profiling. So what are the next steps? Making people more aware about this draft, also outside of this working group, to make people understand that there is this possibility to reuse 8795 for other use cases than just its central network, and to trigger the work to address the reporting of the profile being implementing, and getting more feedbacks and review, because from an author's perspective, the document is now ready for working group plus call.
Yeah, one question. Nigel? Nigel, go ahead.
It's only a quick comment. So first of all, this should be done in 8345, not in TEAS, because the multi-pointed topology requirement is across the board clearly. And secondly, of course, as you know, a multi-pointed link would be a more efficient mechanism, as we presented in the 8345 enhancement proposal. So I'd suggest you do this in 8345, not here.
That was discussed a lot at the time where there was a split. There was a long discussion many years ago on how to split the work between 8345 and 8795. Yeah. Actually, before I started to be very active. So I don't know why the split of function between here and 8345 has been decided. But okay, 8345 clearly states that the multi-point link is modeled as a pseudonode.
Which we're proposing in
alternative. And 8345 does not say anything about whether the pseudonode or even a node has or doesn't have a connectivity limitations. So it's not, when you look at 8345 and you see a node, sufficient. You have no idea about whether you can connect everything or you cannot connect everything or you can connect a subset. No. And these gaps has been already addressed in 8795.
But it shouldn't be in 8795.
It should have not been, maybe yes, but now it's already there.
So we should be taking it back to 8345, making the adjustment and taking it out of your document.
But that means that you are going to have a non-backward compatible change, because you need to take it out from an existing
then
RFC.
You can keep it in and have both, and then say we deprecate it and eventually do it in 8345.
So you want mechanism to deprecate from 8795, but those who have implemented 8795 will live to.
We can deprecate for 10 years. You know, you can do it for a long time.
We always maintain 8795 is a T-aware topology. I mean, it doesn't say that in the title, but I mean, it does include attributes, node and link attributes that aren't necessarily T attributes, but they've always been there. So you can start a thread on that on the TEAS link, a TEAS mailing list, and we'll see where it takes us. But we are talking about taking what is out there and creating multiple profiles out of it.
I understand. Yeah. But we should be doing it in 8345, which is a more generic doc. This is
when you say it has to be done.
This is a generic problem. It isn't just a TEAS problem. It's a generic problem.
When you say it has to be done in 8345, you're recommending it to be done in NMOP.
Is
that what you mean?
Yeah, that's right.
Let's have a conversation offline. I will talk with NMOP chairs as well and see where that work needs to go.
Sorry, go ahead.
But the scope here is to take 8795 and create profiles for it to ensure that it's used for in environments where it's not necessarily T-centric, but there is T awareness. When we say T awareness, T attributes are still at play in that topology.
I have no sort of fundamental problem with that statement, other than we need it more generic than just T. I mean, it's any topology it applies to.
Well, I think the question here is whether the connectivity constraint on a node is the awareness.
Well, I think
that's a problem of
It's
the blurring
Once you
boundary between 8345 and 8795, which was discussed more than 10 years ago. And
we do get things wrong sometimes.
yes, that's fine.
your,
So,
your
what-
point is
what's
taken.
what-
Your point is taken, Nigel.
Well, can I make one more point just about the node, actually, because Itola made a very important point about the node has to be constrained. I completely agree. But once you put constraints in there, then you build a small topology inside the node, which you might as well bring out to the edge and connect up to the edge, and it becomes a multi-pointed link. It's much more efficient than having links to a node. That's the point. It's a much more efficient mechanism. We can go through that as well, just to show that what you put inside the node, you simply have to put inside the link, and then we get rid of all the links around the outside. I think you'll find it resolves to a more efficient mechanism than the pseudonode.
I look at the proposal in
Yeah.
in the NMOP. I don't see any difference in terms of efficiency with respect to the pseudonode.
We can discuss that too.
Yeah, please take it
Okay.
to the list.
Yeah,
Your point is taken.
Yeah,
Thanks.
okay.
Daniele Ceccarelli. So I think this is a very useful work, but with the wrong name in the wrong place, in the sense that we realized that if we keep on calling it TE whatever, people stop reading it after the abstract, because they say my network is not in TE, and so I don't need this, it's overcomplicated, this is complex, etc. So one suggestion, may be wrong, but I just wanted to share it with you. Call it differently, like 8345 enhancements for something that is not TE, and move it try to move it either to nmop or maybe onions if and when it's created, that could be the right place for it, and try to say, so get rid of T awareness, T networks, etc. Focus on everything that is non-TE, that is an enhancement to 8345, and that is needed for other work. CMAP is an example, but maybe there are also some others.
Yeah. Yes, good suggestion. I understand TE is an unpolite word, but well, that's why I started in this document not to emphasize too much TE using YAM model defined in 8795. Which is, we can also go into the direction 8345 extensions. There are two issues, in my opinion, is that there are some data nodes and containers which are already called TE, and the YAM module is already called TE. Changing it to a different name is clearly defining an MBC change. So the one option is to basically create a new YAM data model, which is a copy of 8795 with a different name, replacing TE with something else. But I mean, we are making a big problem to the operators who have deployed 8795, that they have to migrate from 8795 to a new model. Migration is easy. From an vendor's perspective, it's not a big issue. But from an operation perspective, we have to migrate just because the name is better, which looks to me strange, but we make. Yeah. I'm open to that option.
Yeah. No, I'm just wanted to emphasize the fact that, I mean, I've been reading this draft since 0.0 version, and I know that there is a lot of stuff that is useful beyond the TE. But again, people that are not in the TE world stop reading it after the first line, and it's a pity because it's a very useful draft and can solve a lot of problems.
Thanks, Daniel. Chair hat off. I respectfully disagree with what you said. We should, if anybody thinks they don't want to read a document just because there is T in the abstract, then we should try and correct that. But we are not going to fix it in this session. We'll discuss that on the list. Thanks. Any other comments for Italo? Thanks.
Hello, I'm Tony Lee. I'm here to present on behalf of Rand Atkinson, and I like traffic engineering. Traffic engineering is holding up the internet. If you don't like it, all right. The problem we're trying to solve is relatively simple. For those of you with gray hair, you may recall that when we initially defined RSVP authentication, we did it all based on HMAC MD5. This is now showing its legs. It's aging poorly, and it is time to replace MD5. Unfortunately, we hard-coded the structure of the authentication object, so the first thing we have to do is to change that structure. That is our first draft, auth v2, to fix the way things are encoded in RSVP. And then the second draft is how to actually encode an HMAC SHA-2 authentication. So I think I've covered some of this. We are trying to make our encoding general enough so that we can apply other, especially post-quantum kind of crypto authentication to it. We want to maintain maximum backwards compatibility. We want to make this as easy for people to get to as possible. So the format that we are using is to reuse as much as we can of the existing authentication object. We are also trying to reduce all of the operational risks associated with it. So we're trying to make it as much the same as possible, even though it might not be entirely optimal. So we've got a lot of design constraints. Again, backward compatibility is high. We're trying to be multi-vendor interoperable for obvious reasons. That means we're trying to reuse the integrity object and trying not to break legacy parsers as much as possible, even though the contents are going to change. The changes we're trying to do, we now can have authentication data that is more than 16 bytes. This is necessary because the output of new authentication is bigger. This gives us stronger security, so that's not too surprising. We very much want to have security associations that are peer specific. The original specification was not entirely clear about that. We're trying to make sure that that is supported. An integrity handshake must now be implemented. Okay, I'm not going to interoperate without integrity. We've changed the way key management is discussed. Okay. Netconf is a fine option for managing our keys, and we are trying to support that. We took out the discussion of Kerberos because we don't know if anybody is still using that. We don't preclude using Kerberos, but we're not advocating it. And then we created an IANA registry, so if we've got different kinds of authentication, you just register a new entry in that registry and you're off and running. Okay, on to the crypto. We are currently speccing SHA-2, and this is a relatively short document. We have an APAD value. We've picked an arbitrary APAD value. If you don't like the APAD value, if you think that I'm a CIA operative, you're welcome to propose your own APAD value. We're open to that. And then we define things for SHA-256, 384, and 512. That's it. Any comments, questions?
Yes, we have a slight DOS attack in the queue. I don't know why it's not showing. Luberger, if you go back a slide, you mentioned netconf. Why netconf versus Yang? Or RESTconf or GNMI or?
We don't largely care. I mean, we're not precluding any configuration mechanisms here. This is just was already in the document, and we were just going to carry it forward.
Netconf was in what document?
So I think that was in the original.
Definitely not. Netconf didn't exist at the time.
if you would like us to add other things, we're happy to do so.
I think
We're
you
not
should
picky about
switch
that.
to a Yang-based approach, and you shouldn't care about the transport.
Okay.
Hi, the Freilis Christian. Thanks for writing this draft. And what I would say that, I mean, I'm not a crypto expert, and when I read the document, there are many things that I don't understand. So I'm not sure if other folks are in the same boat, and I just wonder what is the plan to get this thing reviewed with the security area to see that everything is aligned, and that review would be very useful for this group.
So the adoption poll was sent to the relevant groups, including SAG group as well. We have also triggered early route security directorate reviews for this. Yeah, I mean, those, and we reviewers have been assigned for those, so that activity is happening.
Okay, thank you.
And we did get comments back from those reviews, and those have already been addressed. So.
Excellent. Thank you very much.
Yeah, there were some offline comments that were sent in by the reviewer. If you can maybe summarize that to the list, I think it will be useful for the community.
They were sent to the list, and I don't remember them well enough to summarize at the mic.
Okay, there were a set of comments that Sean sent yesterday. Maybe those are new. So take a look. At some point when you and your co-authors respond to it, please do keep the list in the loop.
Rand already responded, and I think he responded to the list.
Okay, thank you. I didn't see that.
Okay, then yes, that should get forwarded to the list.
Okay, thank you.
Hello, everyone. This is Luis from Telefonica. I will go through an update of this draft, which is about the DC-aware TE topology model. So just a brief recap of what is intended here. So basically, the objective would be to provide a better view of what could be the resource-related information of a compute domain that is being attached to a topology, right? So the idea is that the cloud managers will be the ones providing the information about resources, and here we are thinking on CPUs, memories, and so, and basically somehow showing with this model the way in which these resources could be reachable through the topology. There are different cloud solutions and will be different cloud solutions along the time. By now, we are just putting a couple of examples here, OpenStack and Kubernetes, which are from different nature. And for sure, there will be new models in the future for sure, because the pace of updating in the cloud space is faster. So basically, we are showing here we can integrate the existing ones, but probably there will be new in the future. Just a reminder, this is the content of this draft was originally part of the draft TEAS service function aware topo model. So basically, we created this spin-off more focused on infrastructure. The other one is more focused on the service functions themselves. So the models considered, as said, we put a couple of examples here. One hypervisor-based example, which is OpenStack. Other one, which is container-based example, which is Kubernetes. So you can see there the update that we provided. So to address some comments, I will go through the comments later on. So essentially, we are, in this example, we have in the compute side the Kubernetes model, which is what you can see on your right. On the left, the bottom part of the slide will be the way of augmenting the TE model. And the red part will be how we link the TE part in the network with the model in the compute side. And the green part, basically, we use the concept, the notion of attachment circuit for creating the hook between both models so that we can basically identify clearly how would be attached the compute information to the PE in the TE topology. And in going very quickly through the model in the compute, As said, this will be offered or provided by the cloud manager, and basically would be fit into the real, let's say, solution. So in the case of Kubernetes, we could have information about the CPUs, memory, and so, but also the workloads and namespaces and so on. For the other systems, could be slightly different. So basically, trying to collect the information that could be realistic for the specific cloud model. So moving forward for making more clear the changes, we received a number of comments in the latest time that we presented this, was IETF 122. We had comments from Lou about the absence of network resources in the YAM model. At that time, we were basically only presenting the cloud part, and also how available network resources will be linked with the network. So basically what I have just commented. Oscar commented or provided a suggestion of including links to network resources. Again, we use this attachment circuit as a way of providing that hook or that glue for that. And Italo commented make a question about if the solution applies only to TE networks or to any network type. In principle, could apply to any network type, but probably the value added here would be to use in the TE network so that we can provide guarantees up to for reaching, let's say, these cloud resources. But in principle, could be generic. We have refined as well the same priority models for the cloud side, the Kubernetes and OpenStack. We also added the new model for integration with the TE, that was that extension that was in the left part at the bottom in the previous slide. And as I said, we leverage on the notion attachment circuit for clearly identifying the attachment between network and cloud environments. So here is summarized, you can see summarized the changes in the document, basically covering these three parts. So basically the notion of what would be the guiding principles, having this separation of concerns, having the usage of attachment circuit for the link, the integration with the TE topology model also being explicit, and basically the point that the model could be generalized. As I said, the three models that we have commented, the Kubernetes, the OpenStack, all of those revisited, and also the way in which we can put the glue with the TE model. So going to the last slide, I think, as next steps, we would like to check if this draft is perceived as a subject for TEAS. We think so, but we would like to know from the working group, collect new comments and suggestions, and refine the models. We are, or me personally, I'm not very skilled on the models, so probably they are not perfect for sure, and there is room for improvement. So yeah, basically go through them and make it better. And our aim is to prepare a new version and keep progressing on the document. And yeah, basically, just to remark the point that the aim here is to get a better integration between network and cloud, and basically with the objective of providing guaranteed services that nowadays are essentially best effort services what we can have in the cloud. That's all. Thank you.
Any questions for Luis? I have a question. Is it fair to assume that you're modeling the T topology of the DCI as not the TC topology itself?
Correct.
You're taking the T topology in the DCI and augmenting the attachment circuits with some additional compute and workload information. Is that the scope of this talk?
Yes, we are not entering on the internals of the data center, neither touching the data center gateway. It's just simply to understand what would be the resources available, the workloads available or attached to a specific border nodes in the topology, in the network topology, let's say.
Okay. The chairs have discussed this briefly, but we haven't come to any consensus among ourselves on how and where to take this. We will discuss with a few other chairs in the routing area, maybe in the ops area as well, and see where this is relevant. And then we will let you know.
Okay,
Yeah,
thank you.
thanks.
Thank you, Pawan.
Hi, my name is Zafar Ali from Cisco Systems. I'm presenting this on behalf of my co-authors. So I start with the problem statements. So in the RFC 3209, there's a section 2.5, and there's N464. that talks about bandwidth increase, what to do when a head-end wants to increase the bandwidth. And this is very common for, let's say, auto bandwidth use case. And what is recommended or what is documented in 3209 is trigger make before break mechanism. However, in a lot of cases in auto bandwidth, where if the customer has deployed ample amount of bandwidth in the network, or is actually bandwidth decrease cases, then we can actually work with a path change on the existing LSP instead of triggering a make before break. And that has advantage in terms of reducing signaling churn, and also you don't have to reprogram your transit LSRs, and you don't have to move the traffic stair from the old LSP to new LSP, which are all part of the make before break procedure. So this draft talks about some details or specifies that can we legalize modify in bandwidth modification along the path. So this is an example of a successful use case of in-place bandwidth update. Here, carefully is chosen that the bandwidth value initially LSP signal, the initial setup, is done with LSP bandwidth X. LSP X is set it with bandwidth 60 megabit per second, and there is a reduction on that bandwidth. So what it says that the path change can be sent with the new T spec of 40 megabit per second, and if we succeed, then we're done. There's no need for doing make before break. Next slide, I'm trying. Yes, so this is a case we talked about for failed sequence. And what can happen is actually in a bandwidth increase case, and this is why 3209 go for make before break, is that the bandwidth is not available at a transit LSR, let's say in this case R3. And there are multiple possibilities that can happen, and that depends on implementation in R3. R3 may send a path error, a non-destructive path error. R3 may ignore the bandwidth increase, and R3 may actually tear down as well. So there are different behaviors because this is in place bandwidth modification is not specified. These different behaviors are possible. But in cases, what it says that is, let's say for instance, if R3 sends a path error or R3 doesn't take the bandwidth update, or the network doesn't take the bandwidth update, so reservation or path error doesn't come up within a specific time, then the head end can actually go and trigger make before break as the fallback option. So what we are recommending is that because of midpoint behaviors, a head end may implement modify in place, not as a default. The default could be, make before break being the default behavior, but modify in place is something that is controlled by policy configuration. And when it is configured at an ingress LSR may first send any bandwidth update message using a path change on an existing LSP. Okay, and this is what is that is clarified. And if in case it receives a path error from the network, or the network doesn't respond to that bandwidth update, then it would trigger. The onus is on the head end to trigger make before break to get the LSP the new bandwidth that it wants. So in the case of the transit node, this basically says that yes, transit node should accept a path change with the bandwidth value change on existing LSP, should admit, and if it's unable to admit, then should send a non-destructive path error. So that's the clarification that the draft talks about. I'm trying to change. Yeah. So from a backward compatibility, like I mentioned, there are three types of things. One thing is a midpoint may do tear down, a midpoint may retain signaling state but not respond in a path error, or may respond with path error. So in the cases which is here listed B and C, the head end would know, and head end can trigger make before break as the fallback mechanism, and it still can work with the legacy or in a backward compatible fashion. And we do not recommend that provider enable this functionality if actually in the midpoint there are nodes that tear downs any bandwidth update on an existing path. Okay, so what we had some conversation on the mailing list, and many thanks for your feedback. There was this conversation around that or even with the original author of 3209, there's a conversation, is it okay? And it seems okay. There are multiple vendors that are doing these bandwidth in place updates. When it was presented last time, Sienna also said that they do this in their product with Himanshu, saying he's unfortunately not here. I'm happy for the correction, but I did reach out to Kamal as well yesterday. And Cisco and Juniper are in that boat. So we feel that it's good to have this clarification done. And then there was another comment, and I think, and I don't want to speak on behalf of other people, but I think overall sense is that yes, it is okay to do this clarification in this document. Another comment was that if this in-place LSP bandwidth update is written as a best common practice in the context of auto bandwidth deployments, and there we feel that in-place bandwidth update is a procedure thing that you can use for auto bandwidth, you can use for configuration bandwidth use cases, or for any use case. It stands on its own in auto bandwidth. If a BCP is needed for auto bandwidth, if the working group feel like it, then we can have that discussion, that auto bandwidth BCP. But we feel that this is a standard track change that should progress on their own. Auto bandwidth is a use case. We can clarify, we can make clarification, and we feel that this document should be adopted. We are requesting adoption for the document and willing to get any feedback.
Any comments for Zafar?
Lou Berger. So I'd love to see that BCP as soon as we have an RFC for auto bandwidth.
Okay.
So there was a comment last time about putting together, since we don't have an auto bandwidth document in IETF, there was a comment about writing a best current practice for RCP auto bandwidth deployments. I think that's a very useful thing to do, and we should take that up. But this particular draft, I think what Zafar was trying to say, again, speaking as one of the co-authors in this draft, to Pawan Peer and HPE, what Zafar was trying to say is this is a specific feature with which can potentially be used out of auto bandwidth environments as well. So there is enough in here for it to be progressed as an individual item. I think that's the case that's being made here.
Yeah, I have no objection to the document. We've had other discussions on it, but I have no objection to the document. I just don't think you should be talking about a BCP for auto bandwidth. Sorry, I don't think you should, in this document, talk about a BCP for auto bandwidth until we have a BCP for auto bandwidth or even a definition. I think there was a PCE document on auto bandwidth that you could steal a lot from, and it shouldn't be a hard thing to write, and it would be a great thing, even though everyone's been deploying for how many years?
Yeah. I believe Rakesh is here to make that exact same comment. We do have PC documents out there, but there isn't. But there isn't a TEAS. But there isn't a generic document that talks about. I mean, we have over the years for the past decade plus, we have been making lots of enhancements in the auto bandwidth area. So having one document that captures all of that was useful for the community. I think that was a comment that was made,
Yeah.
I believe, by Adrian.
I think we're in agreement that we should have a
Yeah.
document. So I don't, you know.
Yeah, thank you.
Thanks, Luke, for the agreement and comment.
Rakesh, you want to?
Rakesh from Cisco Systems. Yeah, I think it should progress as a standard stack document on its own, in place bandwidth. Auto bandwidth can be a separate, there's already a PCE document, and it was very much appreciated that now we have a documentation for auto bandwidth. There was none before. So if there is something can be done, maybe could be kept in mind with the PCE work as well. But this should be a standard track. Only question I had was, have you guys thought about, does it update 3209 in any way? Just a question.
I think we
something-
can have that discussion. What tag should go? So we can have that conversation. But thanks for agreeing.
Yeah, that needs to be
on the
sorted,
content.
but yeah,
Yeah.
we'll discuss it.
Thanks. Yeah.
Matty?
Matthew Bocci, Nokia. So I think this is definitely worth progressing. It's really useful to have this documented because I know this exists in the network. I had a few comments on some of the clarity of the text in there, like about how the LSR is supposed to infer it's supposed to do this. I didn't think it was very clear in the draft, but I'll send you those offline. I don't think it updates 3209. It's not really changing the base RFC. It's just an optional behavior that you can have. It's arguable, maybe it's even just informational.
Thank you. Thank
Yeah,
you,
that's
Matthew. I welcome your comments, and I tend to agree with you on the tag comment.
Lou Berger, I was resisting saying what he just said because I said it the last time, I think. So +1 to Matthew.
Thank you.
So I think that question is closed. So I mean, we are formally requesting the working group adoption, and if you chairs can progress the document and have a working group adoption call, that would be appreciated.
Yeah, I'm a co-author on this. Oscar will go through the proceedings and make a call on this. Thank you.
Thank you very much. Thanks.
Kiriti? We have roughly half hour left. If you can leave Louis 5 minutes at the end, that would be great.
Okay. Hey guys, Kiriti, HPE. Okay. So this is a recap of several documents. The important one being the base document, multipath traffic engineering. While there's not been a lot of changes to it, there's been a change in how we are viewing this. So multipath TE was seen as a replacement or an enhancement of TE for WAN networks. Of course, WAN networks work well for DCE networks as well. But in looking at this, we realize that you can look at multipath TE in two ways. You can say this is an enhancement of a regular TE network by adding multipath to it, or you can look at it as you can add TE to a network that's designed for ECMP. And a network that's designed for ECMP, the classical example of that is a CLO network in a data center, or a fat tree network in a data center. And so once you go down that path and once your mind goes there, you start thinking, is multipath TE a better way or a different way of addressing network issues or network problems that might show up in data centers? And we think that is the case. So we're now sort of doing a mental shift. The draft doesn't really reflect this yet, but a future version of the draft will actually start bringing this out more clearly. So we think that MPTE has applications in deep learning clusters. And the idea that you have a directed acyclic graph and you have this notion of junctions, you can have multiple ingresses, multiple egresses. All of that is something that you can use very effectively inside a data center. So it's no longer outside in the DCI, no longer in the WAN. It could also be in the data center itself. So just to illustrate that, we have a CLO network here, and this is the epitome of multipath networks. So you have the superspine layer, the spine layer, and the leaf layer, and it's set up to be very, very symmetric, very, very structured. And all the links have the same bandwidth, the same length almost, so that they have the same delay. And so this is set up for all that. And this is within a data center, so you have a lot of control. And so you expect to be running very symmetric loads across this. And so that works very well. And so, for example, traffic coming from SS1 going down to the S123 will be equally weighted across all those links. But life starts off very well. But the moment you say I have to do multiple things, so let me just go back here for a sec. If you're doing one giant job here, then you can just treat this as it's a very symmetric network. I'll place my job in a very symmetric way, and this will work nicely. But the moment you say, I'm going to do different things, so I'm going to color my jobs, I'm going to have multiple jobs, I might have multiple tenants. So in this case, you see a blue tenant running on these blue links and using blue nodes like L1 and L2. And you have an orange tenant that's using orange links and using the L3, which is an orange leaf. Then you have to be careful about how do you allocate bandwidth, how much bandwidth are you using on each of these links. So in particular, if you look at the traffic going from SS1, SS2, SS3 to S1, and from there going to L1, L2, and L3, if you have allocated this and you have reserved the bandwidth correctly, then you will not get an overlap of bandwidth between the blue job and the orange job. And so you are getting traffic isolation, you're getting multi-tenancy in a clean way in this very symmetric data center where you have asymmetric load now. So even though you have asymmetric load, you have asymmetric operations going on, you're still essentially able to manage the traffic so that you get this separation. So the point here is that adding TE to a very structured network designed for ECMP will get you to a place where you can use that TE for traffic isolation. If you look at SS1, the traffic that's coming out of it is no longer equally weighted because it is dealing with multiple loads. So the high order bit here is we believe that MPTE has a strong strong applicability in a data center, in a machine learning cluster, inside the data center. Now, equally so in the DCI and also in the WAN, but we are looking specifically at the application of MPTE within the data center. We understand that it's probably not likely that many people will use RSVP-TE here, but MPTE is not tied to RSVP-TE. MPTE is not tied to MPLS. MPTE is a concept that says you can have multi-path traffic engineering, and the instantiations of that could be using BGP, could be using IP tunnels. So if you do that, you get what we call network scheduling. So if you go back to the networking at scale from Meta, this was about 6 weeks ago, they listed out a bunch of problems that happen when you take care of you build your network, you build your cluster, you spend a lot of money on the GPUs, and then you try to run your cluster, and then you find that if the network hiccups, you actually could be wasting 50% of your GPUs, you could be stalling jobs for a long time, you might even have to abort a job. So they've come up with some other ways of dealing with it. Mostly reactive, mostly trying to say, if something happens, this is what we will do to recover from it. And what we think we should do is actually, as much as possible, not get there in the first place. So adding TE to multipath allows you to do network scheduling. So the same way that you reserve compute resources and memory resources in setting up your jobs, you should also reserve network resources so that your jobs don't get hung up on the network part. The other thing that happens is when you look inside the data center, you don't have just unicast traffic. You have multicast traffic as well. So you have all reduce, all gather, where a lot of GPUs are talking to among each other. You have a broadcast job where a single GPU is talking to many GPUs. You have a reduce or gather where many GPUs are talking to one GPU. So you have different modes. So unicast alone is not going to satisfy it. So the goal here is to add, in a similar way that we have MPTE, something called MCTE, multicast TE, that allows you to do multicast while reserving resources. I know that we have point-to-point, point-to-multipoint, and multipoint-to-multipoint TE, but we would like to use the constructs that we have in MPTE to build something similar. So that part was to try to say MPTE and MCTE have applications in data centers, within the data center, within the cluster, and can actually help people get to a place where they're using their GPUs much more efficiently. But of course, MPTE is also useful in the WAN. What it does is combine TE and multipathing with unequal load balancing at every junction. It also supports multiple ingresses and multiple egresses. So these are things maybe you've seen before. That part does not change. What we want to do is just change the place where we are applying this into the data center. One very important thing is that the amount of state and the amount of churn in building a DAG is much less than if you did more traditional methods. Okay, so you've probably seen this in an earlier presentation or at a side meeting. An MPT tunnel is the construct that holds this overall structure. Again, it can have multiple ingresses, multiple egresses. Each node in this is called a junction. Each junction is defined by what are the P hops coming into it, what are the N hops going out of it, and what's the load split across those N hops. So in updating the documents, we didn't update the base document, but we did update the RSVP document and the PSAP document and the Yang model. So the signaling options that we have here are RSVP TE, BGP. We haven't published this yet, but it'll be out before the next IETF. PSAP and programmable API backed by a standard Yang model. So we have the Yang model, and then you can bring your favorite APIs and use them against this. This is important because if you're going into the data center, in some cases, RSVP TE will be a non-option, but BGP is very much the case there. So we will be looking at options within the data center using BGP, options outside the data center using RSVP TE or PSAP, and perhaps even within the data center using PSAP. Prototypes are underway for all of these so that we'll have a better sense of how do they scale, how do they work, how do they interoperate. The tunnel types are also open, so it doesn't have to be MPLS. There are a couple of types of MPLS. And then there are also many types of IP tunnels. The IP tunnels that allow you to have an entropy field are the ones that are preferred. So you can have GRE with a key that is allowed to be an entropy field, or you can have GRE over UDP. Again, you're trying to use some fields within the packet to give you good entropy. When we get there, we will show you how to install fib entries for each type of tunnel. For the RSVP extensions, we made a couple of minor changes. So the base document is how do I signal RSVP LSPs? And The goals, the sort of high order architecture goals were minimize refresh, avoid unnecessary signaling adjacencies, minimize the number of messages going back and forth, and the trigger processing. So in doing all that, we think that we will have much less state and much less churn. So this is a quick summary of the types of messages that you have. One of the big, more important changes is in order to reduce the churn, we've added a version to a junction. So normally, what we had first is the overall DAG has a version number, and if anything changes in the DAG version changes. But that change has to propagate everywhere. So we added a second version, which is on a per junction basis. And so in many cases, only a couple of junctions change, and the DAG as a whole does not change. The Yang model has also been updated, and in the Yang model, you basically have two Yang models, one for the MPT DAG itself and one for junctions. And so these are the Yang model. This is the tree for the Yang model. And you can see that the junction version has been added into this. It's right in the middle of that. Should have put it in red or something. So each ingress can have a separate bandwidth associated with it, because each ingress is going to push traffic into the overall DAG. So each ingress has to be treated differently for that reason. But overall, the rate at which they change things will have to be the same. So so that's pretty much it for the changes for the Yang model. So the next steps. We're going to continue working on this. We have implementations that we're working on right now, which are focused on RSVP and BGP, and we might come back and do some PSAP. There's a background effort saying we have the Yang model, so we can use gRibI or we can use OpenR to also do API-based programming of a DAG backed by the Yang model. So all of those are running in parallel. At some point, when we have some more clarity about how well all this works, I think we'll come back and say, okay, we'd like to propose this, all these documents to be working group documents. In addition, when I talked about how MPT can be used in the data center, we have a companion document in RTGWG talking about network scheduling for machine learning clusters. And so the idea that you're not just scheduling compute resources when you're creating this big job, you're saying, I want to do this inferencing, or I want to do this fine-tuning of an LLM. I'm going to create this job. I'm going to use 5,000 GPUs. I'm going to do whatever else. In the process of doing that, if you say, oh, and by the way, I'll need so much bandwidth on this link and so much bandwidth on that link, I'll need to reserve so many buffers on this node. When you do all that, we believe the job will work much better. Job completion times will come down. So the network scheduling draft, which is in RTGWG, which will be discussed tomorrow, right? That one will come back to tell you why this new application of MPTE in the data center makes a lot more sense. So that's another thing to progress. And at some point, we'll connect those two. Now, right now, the network scheduling draft is an informational. It might get upgraded, but I think the real work will be done in the other documents. Questions?
Zafar?
Zafar Ali, Cisco Systems, 10 Kriti. What I would like, can you go to slide 3-ish, 3, 4-ish? Yeah. So when you get there, Yeah, around this really. Yeah.
This
So
one?
there is, what I'd like to point out is there is a draft in SRv6 ops. It's called AI backend. That is doing these traffic placements and is using SR. And the interesting part is that doing that is in SRS ops because doing this doesn't require any change to SR. And that is because this has been like multipath has been in SR from day zero. So SR supports this multipath and multipath traffic engineering from day zero. I think there's a draft from Andrew as well that actually extend the MPT instantiation in SR. So I just want to point out that doesn't require change with SRT and is there with all the multipath aspects. That's one comment.
Thank you. I'm very happy for you.
Hi, Altaibesh, Cisco Meraki.
Go ahead.
I actually read through your paper because it's very interesting, relevant to what I do every day. I have some concerns, especially around the junctions. How much state is stored in each one of these junctions, and how do you ensure that it propagates all throughout the network? I mean, if there are different data centers or different clouds, you see, and should I go to all the questions at once, or do you want to take it one by one? I have like 3 questions.
So one by one would be good, but so you'll have as many junctions as you have nodes in DAGs. Of course, you can have multiple DAGs. The state that a junction has is literally what are my P hops, what are my N hops, what are the nodes and links that feed into me, what are the nodes and links that I'm going to use to get the traffic to the next step, and what's the load balancing share among the next hops. So it's not a lot of state.
Okay, so just the neighbors.
Yeah.
Okay. How do you prevent then a looping scenario where the DAG is broken, basically there's a looping going on?
So say that again. Did you get the question?
How do you prevent looping?
Oh,
Yes.
yes. So you run a CSPF. I mean, we've done this a lot. So you run a CSPF today. In fact, if you think about regular ISIS, just ECMP, right? You can run a CSPF. It's a very efficient algorithm. It produces one node to all nodes to all nodes, traffic, not traffic, from any nodes, any set of nodes to any set of nodes, shortest paths without TE with no looping. Now, what we're doing here is eliminating some links because they don't satisfy the requirements, the TE requirements. Other than that, we're using the same algorithm. So looping is not seen as being an issue here.
Okay. All right. Okay. Then the third question: how do you handle failures? So every one of these junctions are single point of failures.
That's an excellent question. And in the case where a junction has multiple next hops, you handle a failure simply by saying, I'm going to change the load balancing weights among those. So if you say junction S1 here, and forget the colors for now, and let's just say junction S1 has a next hop of L1 and L3, and I'm just using this picture because it's in front of me. And the link to L1 goes down, or L1 itself goes down. Then instead of load balancing between L1 and L3, S1 will say, I'll send all my traffic to S3. So in the case where a junction has multiple next hops, it just has to redo the load balancing across the next hops. But if it has a single next hop, you'd have to have a different way of protecting that link or that node. And you'd fall back to how we do it today in RSVP-TE, which is to either create a detour or to create a bypass LSP. A bypass LSP is typically shared among a lot of tunnels. detour is specific to the tunnel you're working with, but there are methods to do that. And you have a good point because we haven't written that down. In a future version, we will write down in more detail how failures are handled.
Okay, thanks. I have other small questions. I'll reach offline for those. Thanks.
Okay.
Yeah, please do send those questions to the list. It would benefit the community as a whole.
Yeah, thank you.
Yeah, Wim Hendricks, Nokia. I had a question whether you tested, because you made some statements on that it improved the performance and stuff like that. Have you real tests with like real collective measurements? Because my experience is that if you don't tie into the collective layer, you can do whatever you want in the network. The effect is sometimes opposite of what you are trying to achieve from the network. So my question is really, have you done some tests with real collectives to actually see whether the improvement or the things that you are trying to do are actually helping or solving some of the issues or not?
Yeah, no, so excellent question. I think both on the collectives, but also just in MPT, in a regular WAN network, our goal is to finish the implementation and then say in these different conditions, like I'm trying to do auto bandwidth, or I'm trying to recover from a link failure, or I'm trying to do some other changes. Here's how I would have done it with classical RSVP. Here's how I do it with RSVP for MPTE. And later we might also say we can do it with BGP and others. But for now, let's just say apples to apples, RSVP to RSVP. We have some idea that this will be more efficient, but we're not saying that right now. All we're saying is we have an idea. Once we have an implementation, we'll come back with, here is how these compare. So the best thing to compare, or the closest thing to compare, is what we call container LSPs or TE++. So we say, here's a TE++ set of LSPs, and it carries so much traffic, and it needs this much state. And if something happens, this is the kind of churn that happens. If you do auto bandwidth, this is how you do the auto bandwidth. Here is the same thing with an MPT LSP. So right now, the statement that we're making is we think
it's theoretical at the moment.
You know, hopefully by the end of the year, we have a sufficient implementation that we can come back to you with numbers.
Okay, yeah. I think, what I'm trying to get is if we have real data at some point, I think it's good to share that, because then we can compare somehow.
Yeah, it's an excellent point, and hopefully maybe in Shenzhen we'll have those numbers.
Thanks, sir.
Anyone else?
That's it.
All right,
Thanks,
thank you.
Louis, you have 8 minutes.
So I will present now this work which is being carried out in PC working group. It's about the path computation based on precision availability metrics. So the rationale for bringing here is the following, as you will see. So essentially today, nowadays, the path computation element computes the network path based on metrics, but the system metric object is somehow handle the bounds of the instantaneous metric values. That could be the latency, but basically is looking at a particular point on time, right? However, some services require specification of the behavior in terms of a statistical behavior, right? And this is the case of deterministic networking, .NET, but also is the case of network slices. So essentially, we can express the behavior of a slice according to the SLAs that consider a behavior for 90% of the time, 90.5% of the time, and so on and so far. And it's here where the precision availability metrics can help. The precision availability metrics has been standardized in IPPM, so all of this stuff basically is standard. So this document essentially defines a new precision metric for PCE, so that the PCE is able to select or either calculate paths according to these statistical distributions. So So looking at the diagram at the bottom part of the slide, so the idea would be to express the metrics according to these statistical behaviors. Here you can see a histogram, but could be other ways of expressing the metrics in a statistical manner, CDFs or other kind of distributions. So essentially the point is that according to the behavior, so for instance, I said being able to accomplish the path less than 10 milliseconds, 99% or blah, blah, blah. So we can essentially guarantee that the path that is being built basically historically behaves in the way that we consider, so that we can ensure or predict a behavior according to that histogram in the future. I will not enter in the details, so basically it's to socialize this here in TEAS. I'm basically bring your attention to this and trying to collect comments. I will move to the next slide, which is on how the way in which we are trying to define this new metric. So essentially defining the fields so that help us to define the statistical behavior of the metric. So examples, well, I will also skip the examples, but as it would be essentially to express the metrics in a statistical manner. So for this, we are defining, apart from the metric, or how the metric could be used with different PCE messages for the request, the response, and the error. I'm moving just to the last one, just to comment that we have already presented in DevNet and IPPM. This is why also we present in TEAS to collect feedback from this community. And we will present in PCE session here in IETF 1.4. So the point is to collect feedback from all of you and trying to enrich the document and see it has value as well for TEAS. And that's all.
Rakesh?
Rakesh Gandhi from Cisco Systems. If you go back to, there is a figure where you showed different components. This one. So I'm assuming that for all the links in the network, there is telemetry that's used by PCE to collect all the data for all the links in the network, and that's how the topology is populated, right?
Yeah. Well, we're not entering the solution, but a potential solution for this would be you have T1 or stamp in the links running in the links. You essentially collect all this information and you store the information in the traffic engineering database. So the data will be stored, could be stored, let's say, as a potential solution in an external database. So the PCE just simply consult the database. Being this component the one that creates the statistical distribution, maintain the statistical distribution, and so.
So the what's I could not find in draft is the objective functions. So in PCE, if you see various RFCs for path computations, including latency and other metrics, they define objective functions on how the path would be computed. So it would be good, I don't see it in this draft, it would be good if you can add objective functions using PAM metrics.
Thank you. Thank you for the feedback.
Any other questions? Thanks, Louis. Thanks, everyone. That's a wrap. See you all in Shenzhen, hopefully.